Live from the Creation Museum, it's Flatline. I'm your host here, Rocket Rob, with my co-host here, Danny Faulkner. Why don't you go ahead and say hi, Danny?
Hi, Danny.
Welcome back, guys, for another episode of Flatline. We've been off for a few weeks because of Christmas break, but we are back again. So thank you, everyone, for joining in live. And like we do every week, make sure you post your comments to your social media page, YouTube, Facebook. And we're going to be playing another game here. We have Cheerwine this time. So every time,
this time.
Yeah. We'll just blame on Teddy. So we actually have Teddy in the studio as well. Why don't you go ahead and say hi, Teddy?
You can see that he's sporting his Christmas gift I gave him.
Yep,
He's got a Bengals.
got the Bengals
Cincinnati
on.
Bengals. We're excited about the Bengals here. It was a pretty tragic thing last night with that player
prayers,
collapsing for the Buffalo Bills.
Prayers go out to Hamlin as well, so hopefully he's doing the right prayer for his family and everything like that. But let's go ahead and jump right into our subject tonight, Danny. So tonight we're going to be covering a few different claims that the flat earther community likes to make. You know, the first one being the sun changing different sizes throughout the sky. We're also going to be talking about today about the moonlight cooling different objects. And we're also going to, if we have time, we're going to talk about Polaris never moving, and then also talk about maybe some of the lunar shadows and shadows on the moon. And so, let's go ahead and jump right in.
All right. Well, you know, the flat Earth model is the Earth is round and flat, and the dome above the Earth spins around, carrying the stars, and the sun and the moon also go spinning around. So let's demonstrate this. I've got a little toy soldier here. I got a little story here. This guy I've had for 60 years plus. My dad got a packet of these at the Bargain Barn in South Lebanon, Ohio.
Still got all the paint on
only
it?
one left, but the people in southwestern Ohio and northern Kentucky will remember that place. It's still there, not as big as it used to be. But anyway, bought the packet of soldiers. That's the only one survived. And every year at Christmas, I slip it out and put it in the nativity scene my wife puts out. He's a drummer, and he's
I'm not sure
small.
if you guys can see, but he's a little drummer boy there. He's got some drums there with him. Couple drums.
Anyway,
so.
I'm going to use him as a figure. And Rob, why don't you show us what the flat Earth model looks like?
And then real quick, just want to say hi to Timothy Fox. He's our usual viewer here, so thanks again for joining, Tim. All right.
So you have the flat Earth, and you got the tabletop here, and you have the person watching. Now the sun's going to go around the sky in a big circle, kind of showing a small circle. That's fine. Goes around like that. And the idea is when it gets here, it's at noon, and it's middle of the day. As it moves away, it then gets dim and sets somehow. It doesn't really set. That's another problem for the flat Earth. We'll get to that in a few minutes anyway. But it goes around and around and around, and it just comes and goes. And when it's close to us, it's daytime. When it's far away, it's nighttime.
That's like a spotlight as it's kind of going around.
A spotlight looking down. Now, again, if the Earth is flat, if this is what's going on, the sun is never actually going to set, which is a problem for the flat Earth. We'll talk more about that in a few minutes. But I want to cue into one thing right now, and that's the fact that if you're here and this thing is moving closer and farther from you, then it ought to appear larger and smaller throughout the day. The sun should change its apparent size. And that's a pretty recognized thing. If you know anything about geometry, you can see how that works. And we can use trigonometry to actually calculate how much the sun's size ought to change throughout the day. And I've done that. Trigonometry is not that difficult of a math. The problem is, I've done this, I've published it, flat earthers have not responded to it. Yeah, you can stop now, Rob.
That's really good. Sorry.
But the thing is, the sun, the parent sun ought to change its size as it gets closer and farther away. And I've done a calculation using trigonometry. But the thing is, flat earthers rarely, if ever, use any kind of mathematics.
Right.
It's I think because they don't really understand mathematics. There's a
And
prominent.
it's really basic trigonometry.
Oh,
I
yeah,
mean, you think about it, it's nothing
just sine,
complex.
cosine,
I mean,
just sine in this case.
I don't know.
That's
This
it.
is like freshman level kind of high school stuff here.
Yep.
So.
And it's just surprising that and I've heard flat earthers say that they don't like math. A lot of them say that dismiss it as being all in your mind. It's not really real. There's a prominent flat earther now saying that he's really bad at math. Well, yeah, you are. But just because you're bad at it doesn't disprove that the math is wrong or something.
Right.
You just don't understand the math.
Real quick, Suzanne, thanks for the Happy New Year there. Happy New Year to you as well, and hope you have a Merry Christmas. And also, guys, if you guys want to, go ahead and let us know where you're coming from as well, where you guys located. So it sounds like Suzanne here is watching from Nevada. So welcome in.
So anyway, the sun should change size throughout the day. It should appear largest at noon. It ought to appear smallest as it gets away from us towards sunset.
In the
smallest
flat
at
Earth
sunrise.
model, that's
In the flat Earth model. Now, of course, if the Earth is a globe, and the sun's 93 million miles away. If you go 8,000 mile diameter of the Earth, the sun's hardly going to change size at all. It's going to be the same size throughout the day.
Yeah.
So that's a good test then. Does the sun change size? Now,
again, it goes back to what we talked about before, that predictions. You want to make sure your model is making accurate predictions that models reality here.
Yep. And how well does reality match what you say that it should do? So there are basically two responses that flat earthers have for this. One of them is to produce some time-lapse videos of the sun setting. And when they do that, you'll see the sun shrink in size. So Tom, if you could put that video up for us, appreciate it.
Hello, Joyce from Michigan as well. Thanks for tuning in.
And let me know when he's showing that because I can't see it.
We're good.
And you may want to run it a couple of times there, Tom, because as you look at it, you'll see the sun gets lower in the sky and it indeed gets smaller. And so flat earthers say, well, see, there you've got a shrinking sun because it's getting farther away. Ta-dum, that proves the flat earth model. Well, I think anybody that understands photography at all will understand something here. Yeah. The exposure time, the diaphragm setting isn't changing on that. They've left it the same. Right. And if you set it up early in the day, or well before sunset, you're going to get so much light coming from the sun that you get all this glare, and it blasts out over all of these pixels in your camera.
Yeah, overexposed.
Overexposed terribly. And as you get towards the horizon, it shrinks down because the sun gets dimmer and dimmer and dimmer as it
reddens and dims, you know, because of the atmosphere there. And
so you're not seeing it done properly here. Now, the way to properly do this is to use what's called a neutral density filter to block out the sun's light. And I use the Questar telescope for this. This is an amazing telescope. It has a port in the back here. I can unscrew this port and I can take a camera adapter and I can attach my camera. It's a digital SLR camera, and I take photographs through this port in the back. Now, it's got a 3.5-inch diameter on the front. I'm not going to take the cover off the front, but when I do take it off, lets light through. But then I have this solar filter I put on. It blocks out part of it there, and the rest of it's got a silvered surface, and that reflects like 99.999% of the light falling on it. It allows a tiny percent of light to go through, which is a safe amount.
Yeah,
and you
reduce that glare. It's dangerous to be looking at the sun without the proper filter. I want to make sure everyone understands that. So don't go out tomorrow and try to take some photos of the sun without using the proper filter.
We do sunspotting programs here at the museum, and I always tell them, do not attempt this at home.
Yeah.
One of those things.
Be very careful, guys. Be very careful.
So if you do proper filtering, well, you're going to get some very different results. And I did this back in 2016 on August 3rd. I took 2 photographs with the Questar telescope. I took one of them early in the morning out here behind the Creation Museum. We have an observatory. Most people don't know about that. But I set it up and I photographed the sun as it was just rising above the trees out there. And I took the photograph again at local noon, latest, like 1:45 in the afternoon. That's local noon for us.
Local noon, yeah.
When the sun is as high in the sky as it could get. And I calculated, based upon how high the sun was in those 2 cases, how large the sun ought to appear. And I calculated, using basic trigonometry, I calculated that the second photograph ought to be 6.4 times larger than the first photograph. So here I'm going to put up the 2 of the photographs I took. The one on the left was taken early in the morning. You can see some tree limbs there in the lower right around the 5 o'clock position. Okay. It was just getting above the trees. You'll notice the sun is kind of dim and red. That's because you see it dimming and redding because of scattering in the Earth's atmosphere, well-known phenomenon. And then on the right, I have the one taken up in the afternoon. I was very careful. I used the same ISO settings. That's the sensitivity setting on the camera. I used the same exposure time. Didn't have to worry about a diaphragm because the camera lens is off. I'm using the telescope. So the point is, everything about these 2 photographs is identical except the time of day and where the sun is in the sky.
And you even printed them off on the sheets, and you measured them, and they were within like what, a few millimeters, right?
About a millimeter, so I'll have 160 or so. Yeah. And you can see here, I've reproduced them the same size. I did not blow one of them up. I have an exact same size.
Obviously not 6.4 times.
No, they're the same size, and to within well within 1%. Measured on a piece of printout, which the paper probably doesn't go through evenly enough to be
the paper could have stretched, wrinkled, whatever.
But the point is, it's nowhere close to 6.4 times. So this is a clear disproof of what's required of the flat Earth model. Now, again, there are many flat earthers out there who will show those videos we showed just a minute ago. There are many of them out there on the internet, by the way, that shows the sun apparently getting smaller when it's really just the glare being reduced.
Right.
But then there's a second response that many people take, and this is one that Rob Skiba did. Now, Rob Skiba died a couple of years ago, and I actually met Rob Skiba a few times at the Flat Earth International Conference. There's a picture of the two of us together, and you can see we're both smiling. Rob was actually pretty good to me. I've mentioned before at these meetings, I've met a lot of flat earthers.
He was a Christian, right? Was he?
They claimed to be,
Christian,
yeah.
claimed to be.
We had some theological differences here, but he relied upon Scripture a lot, which I think he misapplied. So we had a lot of disagreements. We got a little testy at points, but our relationship was good. And I want to emphasize, I have flat earther friends. I have some that I can't get along with. It's not my fault. They just really are kind of abusive. Rob really wasn't. He skewered me a little bit in one of his presentations at one of those FEICs. I didn't mind at all. I'm a big boy. I can handle that. But he was kind of playful with me. And that's fine. I appreciate that.
I like his name. He's got a good name.
Yeah, Skiba. You like Skiba?
Rob. No, not Skiba. I like his first name.
So what Rob did is he took a Fresnel lens, and a Fresnel lens is a very inexpensive way of making a large lens. Here's one that it's produced on plastic. And it's, if you look carefully at it, so just concentric circles on the thing. They're actually beveled little lines. It's like a whole bunch of nested pieces of a lens.
Yeah, if you want to.
Yeah, and these were used in lighthouses, for instance, to make direct beams, to make really big directed beams without making a massive single lens. And the neat thing about Fresnel lenses today is you can make a master, very meticulous, very expensive master press of this, and then put the plastic on it, and it just picks up that shape, and you can make millions of these and sell them relatively cheaply. So you can go online and buy these pretty cheaply, and they make good magnifiers.
Yeah.
I can kind of do this with my face a little bit, and I don't know if people can see that at home on my camera, but at any rate,
good.
they're used in magnifiers. So you can use a magnifying glass like this to magnify things. I even have here a little freebie I got. It's a Fresnel lens for a magnifier. You can put it down on your book, and you can, or what you're trying to read, and magnify your image. So Fresnel lenses are used quite a bit. The big advantage for what Rob was doing, at least, is it makes a very large thing. Now, if you try to magnify something with it, which I was trying to show here, that probably isn't going to show, but if you there's a focal length that this thing has, and if you're working within the distance of the focal length, it acts as a magnifier. If you get beyond that, then suddenly it flips upside down, and something very different is happening.
Any basic optics class, you should be able to.
Yeah, optics class will tell you a lot about this. Now, when you magnify something, when you move this and it magnifies, what will happen is you move it away, it will magnify, and as it does that, it's getting larger. So if you magnified my face, you got it centered right here, my face would get larger, my forehead would move up, my chin would move down, my left ear would move to my left, my right ear would move to my right. It would expand outward like that in every direction. And it's important you work on the optical axis, which passes through the middle. So what Rob Skiba did is he took a little circle. He actually put sun flames around it, or some little, so indicates the sun. And he showed that it was as he moved this thing away, it actually got larger, as it would be when you move it away, and it got lower. And so I did this sort of thing. I took one of these circles, put it on here, and if you put this on and you move it back, it will get larger as you move it away. But then I mimicked what Rob did, and here's what I did. I set the Fresnel lens in front of a camera.
Let me hold it.
Yeah, you can hold it like that. The camera is over here to my left, your right, Rob, over here where my hand is right now. I put this thing, and notice the orientation. I'm going to put the circle in the lower half, and I put it on the table, and I move this thing away. And as it did, this thing enlarged in size, and it set. It got lower as it did. So, Tom, if you would run that first video. We wanted to kind of do this live, but that's fraught with problems. You got to kind of set it up right and get it working right. Did he show the thing?
Yep.
Show it again, if you would. Notice that I was able to reproduce what Rob did.
Yep.
But the problem was Rob was working below the optical axis. Remember I mentioned if you did it to my face, my chin would get lower, and it's exactly what it's doing. So instead of orient it like this, what I did is I next flipped the card over, so now it's on the upper half. And when I moved it away, it also enlarged again, but this time it went up. Yeah. So Tom, if you'll show that one. Let me know when he shows it. And then I could also make another screen, this time with on the left or on the right. And as you move it away, if it's on the right, it will move off to the right as it magnifies. If you put it on the left, it will move off to the left. And Tom, I think you have those. Show those real quick for people. The point is, I can manipulate this thing to go in any direction
Exactly.
I want it to go. And I have to ask a question here. Why did Rob Skiba show only one of the four possibilities?
Before we answered that, we had a comment that said, we love Danny's outfit. So I think that deserves a cheer one swig there.
You know what's going on there is Eileen Schultz, who did some volunteer work for us, and her husband, Jim, now late husband, he died a few years ago. He did volunteer work, and a lot of his volunteer work was working with me in the Planetarium with live shows and on the Stargazer night. So I think it was about a year ago. Around Christmas time last year, Eileen gave me this shirt and this hat to go with it.
Yeah.
So I just want to.
Hopefully everyone can see the hat okay.
I don't get too many chances to wear this outfit. My wife doesn't like me to wear it, so that's okay. She's
awesome.
not here.
Yeah.
So that's a cheer wine sip.
Yeah, absolutely. All right, continue.
So why did Rob only show one of them? And indeed, this is a problem. There are four possibilities. Did he just stumble upon that one possibility and that's it? Or did he keep playing with it until he got the result that he wanted? Now, the first one I find hard to believe because again and again and again, I find that flat earthers produce results that I can't reproduce. Well, I can if I work at it, but the thing is, if you handle the things properly, and I'll give you an example of that. We talked a few weeks ago about what they call the black swan.
Yep.
And they take these pictures of distant objects like oil platforms that you're seeing more than you should. And they say, well, this proves the earth is flat. Well, every time I do the experiment, I don't get that result. I can see the curvature of the earth getting away about what I would expect. So I have to wonder, why do they always get the opposite results from me? In the case of the black swan, suppose those kind of photographs, there are atmospheric conditions, temperature inversions, which will cause you to see beyond the curve. But it's a rare circumstance typically. The normal ones, we discussed in that video about the black swan, that the flat earther admitted that most of the time he doesn't get that result. So I think many times flat earthers simply manipulate and use stuff until they get the results they want and then they quit.
Yeah, they're just cherry picking the data. That's what happens.
Well, that comes across as dishonest to me. Yeah. Now, I don't want to make that accusation against Rob for two reasons. Number one, he's no longer with us, and that's not good to talk about the dead that way. But also, I sort of knew Rob, and I don't think he had that sort of attitude. I think in some cases, these people, the flat earthers, they just don't know any better. They think it's okay to use some of the data and ignore the rest of the data or most of the data.
Or sometimes they'll stumble onto that case and they'll stop.
Yeah.
They'll say, look,
Yeah.
prove my point. I don't have to go anymore.
When I first started seeing those videos a few years ago, Rob's videos, I pretty quickly figured out what he was doing. And so I sent off and got a Fresnel lens, got a couple of them, and then I experimented with it. I was able to quickly reproduce what he was doing, but I also showed the other three possibilities that he never discussed. And that's problematic on this. Now, there are three other problems I can identify. Number one, Rob never explained using optics why the atmosphere would work this way. Why they just say, well, the atmosphere acts as a lens. Okay, how does that happen? I know a lot about optics. Took optics in graduate school level class on optics, and it just doesn't happen that way. And we're getting people who don't understand optics at all just hand waving, expecting it to somehow work. Also, they never explained why it always works below the optical axis. Lenses don't generally work that way. Number two, notice in the demos that we did that the sun doesn't maintain the same size. The sun actually gets larger. And so, the expectation is it should get smaller. It doesn't. He's trying to make it look the same. It doesn't. It gets larger. And I think what he was thinking was that, well, this getting larger will kind of cancel out the apparent getting smaller. But the thing is, when you do the experiment, because you're moving it away, it actually is getting smaller. So it's already factored in. It's still getting larger. It's a fundamental misunderstanding of how a magnifier works. And again, the third problem is he was working below the optical axis, and I don't know if he understood that or what was going on there. But
yeah, ignorance could have been part of it too. And of course, we don't say that about every flat earther, that they're just going to be ignorant about these. And like you were saying, some of them really are doing it dishonestly. I think there are a lot of charlatans out there, and they know exactly what they're doing. So of course, we want to make sure we don't put a blanket statement across all flat earthers, but that is a possibility.
Has there been any comments about this part.
I just had to say hi to my wife here. She says Merry Christmas and a Happy New Year, so I think that deserves
That sure does.
a swig as well. And by the way, guys, if you want to catch up on any of our previous episodes, I think all of our episodes are on Facebook Live as well as our Creation Museum YouTube channel. So if you guys want to binge watch the latest Flatline episodes, feel free to jump on there. And this is something that we mention each episode as well. Danny has a book called Falling Flat, which is a really good resource if you guys want to dig deeper into this. Because, I mean, of course, on this program, we're not going to be able to cover every detail regarding a lot of these topics. And some of the topics that we're talking about tonight, Danny does a really good job explaining it, just breaking it down in this book. So if you guys want to get a head start on that, you can jump onto our Answers in Genesis bookstore online, or you can go into the Creation Museum as well, pick it up at our bookstore, as well as plenty of online articles and blog posts from Danny if you guys want to read more about this. And so that's just something that we always encourage people to do. Just stay curious, look into this information on your own, as well as Danny's YouTube channel as well. So Danny has some good stuff on his YouTube channel.
I have a YouTube channel. If you go there, you'll see I don't have too many followers. That's because I don't really promote this thing at all. I've taken some educational things that I've done, a lot of time-lapse videos that I've done, and some of the ones we're showing tonight, and I've put them on that channel. You can go there and check out my content. Again, don't be surprised not many people have been there because, again, I've not really promoted it. I don't want to get swamped with a bunch of things anyway. But it's there just for educational purposes, and I have some flat earth, anti-flat earth content there.
And if you guys are interested in the math too, I think you have an article that actually kind of breaks down a lot of that math you were talking about earlier.
Yeah.
If you guys want to learn more about that trigonometry and basically what Danny does is he sets up a ratio of measurements and he's able to use that to then come up with how big the size should be. And what I thought was interesting from that article, Danny, basically what you were saying is if you use that ratio, if you were to compare an altitude of 1 degree versus, what was it, I think 63 degrees, right? The sun ought to be 50 times larger. Obviously, that's
as you go down towards the sunset.
If you
get close to 1 degree up,
that's 50 times bigger. Obviously, that
isn't
not
what we're
even
seeing
close
at all.
to be
No,
unrealistic.
No, we're seeing the same size the whole time if you use a proper neutral density filter on them.
Exactly. So obviously, that doesn't match reality.
Okay, the second thing we wanted to talk about tonight was the moon's light. And this goes back to Samuel Rowbottom, the guy that started the flat earth movement back in the 19th century. And I've used this thing many years. It's a half painted styrofoam balls, black on one side, white on the other. And I use this to illustrate the cause of the lunar eclipses. And that's caused by the moon moving around the earth. The lit side faces the sun the whole time. And as it goes around, the amount of the lit portion we see changes. So you go from waxing, people are watching on that other screen, waxing crescent to first quarter, to waxing gibbous to full, and then waning gibbous, third quarter, waning crescent, and back to new again. And this is a good way to illustrate how that happens. Now, I think Rowbottom in the 19th century realized that if that is what causes lunar phases, then the flat Earth is in real trouble. Because, for instance, when there's a crescent moon in the evening sky like this, it's pretty clear that the sun, if it's illuminating, is below the horizon, and the sun can't pass below the horizon in the flat Earth model. So that's a problem. And so the way he dealt with that was simply to deny that the moon reflects sunlight. It has its own light, and they do give a Bible verse or two that talks about the moon having, its own light. And they insist, it says it has its own light. It can't be reflecting at all. And I don't want to get into that right now, but that's a misapplication of those passages. So if the moon is not reflecting the sun's light, then what caused the phases? Well, flat earthers never give you an answer. But to drive this home, Samuel Rowbottom pointed out that, look, the sun's light is very warm. If you leave objects sitting out in the sun, they will have an increase in temperature. So it stands to reason if what we're looking at when we look at the moon is reflected sunlight, then the moon's light ought to increase the temperature of things too.
Vince just said, "I love you, Danny Faulkner and Rocket Rob Webb." So I think that deserves a swing.
Very good.
Rocket Rob. Yeah.
So what he didn't realize was to actually run the numbers on this. As it turns out, the sun is about 500,000 times brighter than the full moon. And that's, if you really appreciate how bright the daylight is, you begin to understand that that's true. But I've
400,000, right? Times brighter or something
about 500,000, close to 500,000. That's a full moon. Now, I've actually measured this, Rob. The way I did this is I actually did it for a waning gibbous moon, which is nearly as bright. I was set up the camera to record stuff at night, and I recorded the moon rose, and I got this landscape lit up with moonlight, nearly full, not quite. And I then just left the camera out, came back the next morning. This is like 2 or 3 or 4 in the morning, probably. The next morning, about 10 o'clock or so, I photographed again, where the sun was about the same position of the sky the moon had been the night before. I had to change the ISO, the exposure time, the diaphragm setting. If you know much about photography, all those are done in factors of 2, so you can compensate for light levels. And that allowed me then, what I did is I took a bunch of pictures in the daytime, the same landscape, illuminated now by the sun, not by the moon, and I picked out one of the pictures that I thought closely matched what the moonlight looked like. I then looked up the information that's on the JPEG that comes on a camera. It gives me the ISO, the diaphragm, all that kind of information. I then did the calculations that any photographer would do, and lo and behold, it's like 800,000, which for a waning gibbous moon would be a little less than a 500,000 difference, or a little more than a 500,000 difference. So it's the full moon is 1/1,000,000th the brightness of the sun. Well, let's suppose you left something out in sunlight, and its temperature raised by 50 degrees Fahrenheit. It stands to reason then that the object would raise its temperature by 1/2,000,000th of that if it's the full moon looking at it. Well, if you do that, you'll find out it would change the temperature by 1/10,000th of a degree Fahrenheit. I don't have any device that can measure that small of a
Obviously,
temperature
really
change.
difficult to be able to detect. Yeah.
And then you have
Right.
confounding variables. I mean, if I stand next to it, my body heat would probably swamp that. So obviously, you're not going to detect heat coming off of things.
Not much.
And Rowbottom in his books in the 19th century referenced, I think, 2 articles where such a study was done and found no temperature change. But then he had, really weirdly, he had a third one that indicated a cooling that took place. Now, it was a few years later, 1901, David Wardlow Scott wrote his book on flat Earth, relying upon Rowbottom, and he really ran with that. And he said, look at this, moonlight is cooling, moonlight is cooling. And so flat earthers now just say moonlight is cooling, which is really weird because it really has nothing to do with flat Earth. But
Nope.
you know, right off the bat, that would violate everything we know about energy because we know in light is
and
energy, and energy light contains energy. So how could energy of light suck energy out of things? That's what heat is. It's energy, which makes no sense if you understand anything at all about heat and energy.
Right.
Now, what they do is they'll go outside, they'll take they call these laser thermometers. They're really not. It's got a laser on it that will light up where you're pointing the thing. I got it pointing here on the tabletop.
Yep.
That simply tells you where it's pointing, and you'll read a digital readout. I've got it in Fahrenheit on the scale here. It's reading the wall behind me.
Yep. 68.
68, reading the wall over there. If I put it on me, it ought to read something warmer, right?
87.4.
There you go.
There you
Yeah,
go.
you read part of my skin here. Now look in my eyes, of course. Don't point lasers at people's
you don't
eyes.
want to do that, guys.
So what they do is they go outside and they take these infrared thermometers.
Infrared thermometer,
And
yeah.
they're always saying lasers. They're not. They're infrared thermometers. They're
Right.
lasers merely for pointing. And they'll look at objects in moonlight and they'll record the temperature, and then they'll put it on something that's not in moonlight, and they'll say, "Hey, look, the one in moonlight is warmer."
Yep.
And there are
See a bunch of YouTube videos about this.
there's countless videos out there on this. And of course, I realized what they were doing almost immediately. And I went out and did my own sorts of experiments. And Tom, you may want to go ahead and put up the link for my reporting on this, and people can do this. And I did 3 different experiments, actually, repeatedly did 3 different experiments. One of them I did is I got one of these infrared thermometers, and I went outside when the moon was out and measured stuff. And what I found is I could get any results I wanted because I knew what I was doing. I could get the same results that the flat earthers are claiming, that things in moonlight are cooler than things not in moonlight. I could get things in moonlight that are warmer than not in moonlight. I was able to manipulate those things all around. How did I do that? Well, I had to look at the surfaces.
Right.
If you're looking at different things, it's going to record differently because, as it turns out, these things don't record temperature directly. They record emissivity, which is different. And so things that
Infrared
are
emission coming off.
different substances but the same temperature will give you slightly different
Yeah, the
temperatures.
color, the composition, those things matter.
Yep. So it's important you use the same things. And most flat earthers attempt to do that. But here's the other thing. And I mentioned confounding variables a moment ago. There's a huge confounding variable here they're not aware of for the most part. It's called radiative cooling.
Yep.
If you're going to do this with the moonlight, it has to be on a clear night, doesn't it? I mean, if it's cloudy, like, last night the moon was bright, but I didn't see the moon because it was cloudy, it even rained overnight.
Yeah.
So you need a clear night, but on a clear night, you get radiative cooling of things on the surface of the Earth. and things will radiate away heat into the night if there's no wind particularly, but if night's clear, and the clearer it is, the more it will do that. And now, that's the reason why you get dew and frost formation on objects that when there's no moisture, well, there's no rain or no fog, if the air temperature drops down to the dew point, then water will condense and you'll get fog. But if you have a glass, in fact, the outside of these cheer wine bottles are damp. They've got condensation. You can feel that on there. Every time you pick it up, you can feel that condensation. That's dew that formed out of the air because this is chilled, and the air comes in contact with it. It cools down. It reaches the dew point. It's got to get rid of that water.
Yeah, and you think about just if you guys have a carport, park your car underneath that carport one night and then do it the next night outside of it, and you'll see there's
You
difference
won't get
in
any
that
dew or
too.
frost. That's what a carport does for you. Because that radiative cooling allows things to cool lower than air temperature. People don't realize that.
And a lot of these videos are doing it underneath like the canopy of a tree, for example, and they'll say, "Look, see, it's warmer over here. It's cooler, without."
And so what I did is I set up experiments. A lot of times I did grass because that's easy. I got an open yard, but I did also some other things, some wood and brick and things like this. I did this like, I don't know, dozens of times, probably about 75 times on different nights. And I would go out and I would do 4 different things. I'd have an object like grass underneath the canopy of a tree, which would keep it from lowering its temperature. I did it where it was under a canopy of a tree, but still moonlight was getting to it. I did it where it was not under the canopy, but still shaded from moonlight from something, and then also no canopy and moonlight.
Right, 4 different cases. And if you guys want to learn more, I think you have an Answers Research journal
It's
about this, as well as an article.
Tom should be putting that article up at some point
so
here.
if you guys want to learn more about that and all the details.
And what I did with this infrared thermometer, I'd go outside with a tape recorder, or just a recorder, not a tape, just a recorder, and I would point it down and I would just read off 10. I would let it run for about 3 or 4 times. It updates every few seconds. I let it run for several cycles, so I wanted to get it settled down.
That's what you do in good science, right?
Yeah.
You do repeated observations.
And I
over
would
over
read
again.
out a bunch of these, at least 15 or 20. I didn't know how many. I wasn't counting as I went there. Just read out what the readings were. And I'd do this for the 4 different samples. I would go inside, and then I would transcribe it, play the tape recorder back, and I would put it in an Excel spreadsheet. So I would do an average of those 4. And then I did analysis. I would do the different, pairing them up different ways and finding the differences. And when I accounted for this properly for radiative cooling, every time I did the experiment, I found that there was no change in moonlight, which is what I expected. I pointed out there's not enough energy there to be heating, but certainly it's not going to cool unless you're going to violate everything we know about light and energy.
Essentially, you found the warmest cases to be underneath the canopy of that tree.
No matter if there's moonlight on it or not.
Or not, yeah,
And I think many
exactly.
times if you go outside to do this experiment, it's going to, the easiest way to get moonlight is to do it with no obstruction overhead, so you're going to get radiative cooling. And the easiest way to do a sample where there is no moonlight is to put it in the shade of something, which means you've probably got a canopy overhead again. So you got a confounding variable here, and a lot of flat earthers don't realize
And you
those
did this
confounding
multiple
variables.
times
Oh, yeah.
over multiple months too.
Oh, yeah.
So it's not
Throughout
just the
the year.
same time period, but over multiple months as well, so you can get that good range there going.
Now, another experiment I did, I only did this a couple of times because it was an all-night deal. I did it during bright moon. I have here a bulb thermometer. It's got, they used to put alcohol, mercury, now they put alcohol in them. This thing has slid down a little bit, but it's got a cork on here that is 1 1/4 inch, a little smaller than that, and that fits in an eyepiece holder of a telescope very nicely. It's got a hole down the middle. I was able to slide this thing in here, and I use a 16-inch telescope we have. It's a big reflecting telescope, big mirror, this big around out there. And I one day was trying to find the focal point of that thing, using it on the sun. I put a piece of white paper up. Within 1 to 2 seconds, it burst into flames. I mean, it didn't just brown up; it just turned into flames.
That's fun.
It was really fun. Much better than ants and stuff and leaves they did with a magnifying glass when you were a kid. This is a big one. So it does a good job. And what I did is I got this at the focal point, and that allowed me to focus the light of whatever I was pointing the telescope at the bulb in this thermometer, and I would point it at the moon for 5 minutes, and then I'd read the temperature.
5 minutes.
Then I'd move it off for 5 minutes and record the temperature, move it back in. I did this for hours. And what I saw was a gradual trend in dropping in temperature due to the telescope cooling down. It cools down because it's out at night, it's a clear sky, radiative cooling again. But if it were actually a warming trend, I mean, a cooling trend of the moon, you expect every time I look at the moon, the temperature would drop and it would rise again when I moved it off the moon and drop again. It didn't do that. I saw no evidence of this. So again, I've done extensive experiments.
And you've even done an experiment, I think you talked about in your book as well, where you took a piece of plywood
Did
and
that
you
too.
had one end in moonlight, the other end in shade, and then you would flip it over,
And
you
I
would
spin it
rotate,
around.
swap around, you do all
I did it
sorts of-
4 different ways, each
Yeah.
either end, and then I'd flip it over and do it either end
each
again.
time over and over and over
Yeah.
again, just which is important because you want to be able to account for any possible differences between the ends of the
That's
board,
it.
which I thought was important.
That's how good science is done.
Yeah, exactly. And you did it over and over again. You saw no evidence of the moonlit side versus the shade side being a different.
Well, no. The only thing that was different was a canopy.
Yeah.
Did you have something over top? Now, what I see a lot of these flat earthers, the guys that go out and he'll point this thing on something, and look at that. Look at the temperature. Man, it's 75 degrees over here in the moonlight. Though it's only 70 degrees. That proves it. And many times I have no idea what they're pointing the thermometer at,
Yeah.
and I certainly don't have any sense of what's overhead blocking it. And again, I have to ask the question, these guys go out. Every time they do this, they get results of moonlight cooling.
It makes you think if it's like a sleight of hand type of thing that they're trying to pull on us.
I mean, you'd think occasionally they would mess up and they would get the results I get, but they never do. So are some of these people, again, I think are just faking people out. They know what they're doing and they're intentionally doing it to people.
And just to give you guys an example, you think about like a row of pavement is going to be a little bit warmer than grass or dirt
Yep.
because of that emissivity.
And as I said, I can go out and I made a little video once where I did that. I went out and got any results I wanted just by carefully picking where I
Just
did it and
based
what
on
I
the
did.
composition, what material you're using. Yep.
And other people, though, I think, again, maybe they're not intentionally being deceptive, but they go out and they keep doing this experiment until they get the result that they think is the right one.
Right.
But that's not how you do science.
No, that's not how you do
If you get results that contradict what you expect, then either it might disprove or what you're trying to prove, or it might suggest confounding variables. And so you need to do the science right. And unfortunately, flat earthers don't do such a good job on
And
that.
when they see these kind of evidences, these claims, what's the usual rebuttal from the flat earthers? What do they usually say?
Well, there was only one person I know of that took me on. He wrote a book and he really excoriated me on this. And he was accusing me of using the wrong substances. He said I should have used metal because that would work better. Well, the problem is no one ever said that before. They never said metal only works on this. They said, objects left in moonlight. And suddenly he's saying, well, I'm doing it wrong. And he also was saying, he was talking about what was he talking about? He meant, it's been a while since I've read this now, but he was talking about, he was confusing the conductivity of substances with the thermal coefficients of things. How much heat it takes to cause these things to heat up. And he consistently confused those two. So he was the only person that took me on. He was accusing me of all sorts of deceptive practices.
I was just thinking a lot of these flat earthers, I'm going to bet they probably either ignore or just deny the evidence.
Well, for
completely.
most of my work has been ignored. For the most part, my book has been ignored. I've only known one flat earther who actually went the time to look through it, and he misunderstood many, many things. The guy's name is Anthony Riley, a.k.a. Sleeping Warrior. He did a YouTube video where he went through and just page after page, and he was getting stuff wrong and misinterpreting, misunderstanding. He even, we argued back and forth, the two of us. He was saying that I had a whole book on gravity, a whole chapter on gravity, and I didn't discuss general relativity at all. I said, that's false. We went back and forth. I said, prove to me that I have a whole chapter on gravity, and with that chapter I didn't talk about general relativity. Finally, I made my point. I thought I was forced him to go back and look at the book, and he never did get it. Here's the point. There is no chapter on gravity in that book. There is a subsection or a section in a chapter on physics about gravity. And finally, I pointed out to him, I had to tell him about 5 times before he finally got it. He said, well, you call it a section, I call it a chapter. I said, no, it's my book, I call it a section. So, yeah, most of the time they ignore these things, though. Anyway.
By the way, I think we still have that slide up. I don't know if you want to
Oh,
advance
I'm
the
sorry.
slide there,
I should have switched over this. This is, I'm so sorry,
realized.
Tom. This is
Sorry, Tom.
this is the, if you go to our website and you look at the search for this thing, you'll take the link we give you. It's going to look like that. Testing a flat Earth prediction is the moonlight cooling. And again, as Rob pointed out, I did this over many, many months.
Which is what you do as a good scientist.
Repeated the experiments again and again and again, and I never did find results that flat earthers like. I got close a couple of times, but every other time it was very clearly not what they were
I
claiming.
mean, is it safe to say that these flat earthers, they like to stay in their own little tiny domed world, their own
pretty
ignorance of
much.
reality?
Yeah. Any more comments from people about this?
Let's see here. So we had one. See, Alex asked Professor Faulkner, "Are you a descendant of the famous author?"
No. I am probably distant related. My people are from eastern Kentucky. They arrived there by 1800. William Faulkner was from Mississippi. But Faulkner is a Southern name, pretty common Southern name. If you went back 8 or 10 generations, you'd probably find a common ancestor, but I'm not aware of any direct connection between us.
Okay.
People want to know further. My people originally settled in Powell County, Kentucky by 1800 along the banks of Red River.
There you go.
It goes way back.
By the way, Danny is a huge Red River Gorge fan there, so
It's my favorite place in the world. By the way, we do field trips there. We got one coming up,
That's
I believe, in
right.
April.
Coming up.
So if you want to go to Red River with me as your guide, sign up. We still have some availability on that. If you love
Yeah.
arches like I do, and you'll have a good
I've
time.
gone one time with Danny, and I don't know.
Well,
It'd
Rob,
be
that
hard
wasn't
to go
fair.
again.
We took you off trail.
One of the hardest hikes I've ever done in my life.
It was the worst off trail we'd ever done. On our trips we do with Answers and Genesis, we stick to main trails. It's an
The main
easy
ones
hike.
are easy.
Yeah,
so,
yeah. We took Rob back in the spring, I think, and it
I
was.
think it was last year, yeah.
And we took you again. My other hiking buddy and I. We told you, we kept apologizing because it was the worst hiking we had ever done off trail.
Worst I ever done.
Yeah, I've never done it before or since like that.
One of the things, just going back to speaking about the moon, this is basically something that we're talking about today, guys. This is something that you can do on your own very easily. These are simple
Yeah.
observations you can do on your own. You don't need any super fancy equipment to do these kind of things. Or I was just thinking about the moon size. You think about the moon size during moonrise, and then when the moon's
Yeah.
high above, you can actually do that calculation as well. See if
yeah.
the moon's changing in terms of size. And
No, part of the problem you have with the moon is the moon, when it's low in the sky, it looks large. It's called the moon illusion. It's an optical illusion. But you know what? If you look at it through, say, a tube that wrapping paper comes in, it looks the right size. And of course, cameras don't lie. So if you got a camera with a zoom lens, take a picture of the camera of the moon when it's low in the sky, take it when it's high in the sky, and it will, if the settings are all the same, they will be the same size when you print out the pictures.
one of the other things I was
Works for
thinking
the
about-
moon and sun both.
Yeah.
We could talk about the moon.
One of the things I was thinking about too, Danny, is like you think about the sun, moon, and the flat Earth model. You would expect it to actually move faster, right? Once you get close to zenith, and then it should kind of slow down.
Yep.
Once it gets close to the
Well,
horizon.
the thing
which
is that that's generally true.
is what we know.
When something, that's a good point, I forgot to mention that, thank you. When an object is moving at a constant rate, when it's close to you, it seems to move very quickly.
right. You think about like a car, right?
Yep.
Moving at the same speed, it's going to move much faster once it goes by you, and then it's going to slow
Yep.
down as it's going farther.
And the sun and the moon don't do that.
don't
They
see
move.
that,
They
yeah.
move about a 15 degrees per hour constant rate, and so that violates the thing of the flat Earth model. So you've got several ways to attack this thing with the sun, and it just doesn't work at all. And the moon
Obviously,
doesn't work
it just
at all.
doesn't roll.
No, it doesn't roll.
Flat Earth doesn't roll, but the globe model, it rolls.
Let's move on to our next point about Polaris. The
right.
flat earthers claim that Polaris has always been it never moves in the sky. It's always been the North Star, and you've got a dome over top of the Earth. They say, and so I've taken this on. An article, does the North Star Polaris prove the Earth is flat? And our idea is you got this dome over top of the Earth, and Polaris is at the top of this dome, and this dome spins around, so the North Star never moves. And I will grant, if you look at the moon, look at the North Star with the naked eye, it appears to sit still throughout the night.
Yeah.
But appearances can be deceiving. And so what it turns out, got a point in the sky called the North Celestial Pole, around which all the stars in the sky seem to spin around. And the moon is the Polaris is about 3/4 of a degree from that point in the sky. So in reality, the moon goes through about a 3/4 of a degree circle every sidereal day.
You have
which
that
is,
on your shirt.
yeah,
Where is that?
somewhere on here. Anyway, it's about a little less than a day, 23 hours, 56 minutes, and 4 seconds. So I came out one night and I put my camera that I used on the Questar, I mounted it onto the 5-inch refractor we have here. It's got a 660 millimeter focal length. And I came out when was it? Back in April, was it? And it took me 3 attempts to get this right. And so I did this. And if you go ahead and put that video up, if you would, Tom, I have a time-lapse video here of 1,165 photos I took over 10 hours. It runs from dusk to dawn. It was on the night of April 14th, 15th of this year. Each one's a 13-second exposure, ISO 200 with my camera with information. I can give you if you need it. But do you see it spinning around there? That brighter star that started up on the upper left, that is Polaris. And you can see it's moving, and the center of motion is somewhere near the middle of that video.
Right. Yep.
And you have to time it just right to get it perfectly done there. And you see it started at dusk and it runs to dawn. And that clearly shows that Polaris does not remain motionless. To the eye, it seems to, but with a anybody can do this for themselves.
Right. You can do this by yourself.
If anybody who doubts me, get a telescope, even a cheap one, with a moderate magnification, set it up in your yard, point it at Polaris, note where it is in your field of view, and then walk away from the telescope for about 4 hours and come back out later and look at it, and you will find that it would have moved because it goes to that circle. Is it finished, Jeff, the video?
Still going.
Yeah.
But,
So keep watching it. Now, it turns out I did unveil this back in the spring, and there's a flat earther out there. We've locked horns a few times. His name is Bob Nodell, and he heads up a group of a YouTube channel they're called Globe Busters. And when this came out, they discussed it. And they looked at it, and they obviously didn't pay much attention. They were asking all sorts of questions. Well, how did he do that? What's going on here? Well, if they would have actually looked at the video and the description, they would have answered all of their questions. So they didn't bother to do that. They noticed there's a slight jump towards the end, and that slight jump occurred when the battery died on the camera, and I had to pull the battery out, replace it, put it back in, and that lost about 5 minutes. So I lost some of the exposure there. They assumed that was some sort of trickery involved. Well, look, if I'm going to do trickery, I'm going to be much better at how I hide this. It's just there because it was a small time gap. It takes time to replace that battery in there. It's really kind of senseless. I mean, what if the moon, if the Polaris, is not right at the center of the motion? It does move in the sky throughout the night. Does that really threaten the flat Earth at all? They could accommodate with this as no trouble. So I don't understand why they dig in their heels.
What I was thinking.
They dig in their heels just like they do on the Moonlight cooling.
Right.
And it makes no sense. But
it has nothing to do with the
No,
flat Earth itself.
not really. But you know what? Polaris also hasn't always been the pole star. They say it's always been the pole star for thousands of years. Navigators have used it. As it turns out, navigators typically don't use Polaris for a couple of reasons. You can find your north direction pretty good. You can maybe get your latitude, but it does nothing about your longitude at all.
Yeah.
But you can look up the position. And I have here a couple of issues of the Astronomical Almanac. This is from 1994. That comes out every year. And it used to be a long time ago, it was the American Ephemeris and Nautical Almanac.
There you go.
It's got a lot of information in here, which would be of little interest to most people. Astronomers like it. And they have each year the bright stars. This is from 1994. And right here you'll see Alpha Ursa Minoris. And it gives you its right ascension and declination. And the declination is like latitude in the sky. And that declination tells you how far from the celestial equator it is. If you take the complement of that, it tells you how far you are from the celestial pole. And for 1994, at least, it was 89 degrees, 14 minutes, 23 seconds, which is just short of 15 minutes, which would be exactly 1/4 of a degree. So in 1994, it was a little over 3/4 of a degree. But every year you look this up, you will find it's slightly different, different.
Yeah, every year it's slowly increasing, right, per year in that declination.
Well, it's increasing. It will do so for about another 75 years or so.
Right.
Late in the 21st century, it will reach its closest approach to the North Celestial Pole. Then it will start to move away.
Yeah, this is just the modern data that anyone can look up, right? I mean, you can go online. You can
Oh, yeah.
jump online right now and
I
look
think
that up.
these are actually online someplace.
Yeah,
But if
yeah.
you look at Wikipedia, they'll give it to you right now for probably 2023. But if you look at another year, 2024, it will be different again. And it's caused what's called the precession of the equinoxes. It's a gradual shift in the coordinates in the sky because the North Celestial Pole is moving with respect to the stars because the Earth's rotation axis is
Think
doing
about
this.
like a spinning top, right?
And this has been known, by the way, for 22 centuries or so. A guy named
long time.
Hipparchus discovered it in ancient times by measuring
long
positions of objects. So in this article I have here, I list some of these measurements out of such sources. I also went and looked at historical sources. I looked at measurements done by Copernicus. I looked at measurements done by Ptolemy and
Ptolemy
others.
as well,
And I was able to find out what they were. They expressed it many times in a different coordinate system, but it's easy to transform. And I found out a few hundred years ago it was several degrees away. It was really Polaris was not called Polaris or the North Star, pole star, until about 500 years ago.
Until after Copernicus, right? It was kind of around
About
that time.
that time.
Yeah.
It was in 3 or 4 degrees at that point. People said, hey, this is a useful pole star. But for 2,000 years ago, there was no pole star. And in the southern hemisphere, there is no pole star. And this changes. It's been, if you take the conventional dating of the Great Pyramid construction in Egypt, the star Thuban, which is in the constellation Draco, was close to the pole. And in another 12,000 years or so, Lyra, one of the brightest stars in the sky, I mean, Vega in Lyra, the constellation Lyra, one of the brightest stars in the sky will be the pole star. It'll be a really impressive pole
And
star.
just to summarize here, for it to be exactly motionless and for it to be at the north celestial pole, its declination must be exactly 90 degrees, which it never will be,
Yeah.
right? It never was and never will be at that
So
angle.
throughout the night, its position does change slightly. It's not a huge amount. But even more importantly, when the flat earthers claim that the pole star, the North Polaris, has always been in the same position, never moved, that is patently false. We have adequate, more than adequate historical records telling us where Polaris and many other stars were. And if you wish to go to this article and look at what I have to say there and read the
And
stuff
it's not
up.
just professional astronomers. I mean, amateur astronomers. I mean, they do these measurements all the time.
Oh, yeah.
And this is something that's very common. You can go out there and
Yep.
find it on your own,
Oh,
guys.
the precession of the equinoxes kind of messes things up. When I was starting out in astronomy half century ago, it was problematic for me. You can dial in on your telescope axes. It used to be mechanical, now it's done electronically. What are called the coordinates, right ascension, declination, like longitude and latitude on the Earth. But you have to update it each year because of that shift I was talking about. And we do that regularly at the observatories. Now we do it electronically. We just simply put in the coordinates we have. We give the epoch what year it was, and it will transform to the current epoch, and away you go.
Yeah.
And amateur astronomers do this all the time. If you don't believe me, find an amateur astronomer who's pretty serious and ask them about that, about updating. You have to update them all the time. All the constellations, all the stars' positions are slowly changing in the sky. That's a problem you have to deal with if you're serious about pointing a telescope.
But again, when you bring up these type of observations, these evidences to flat earthers, I mean, again and again, the typical rebuttal is just this empty conjecture, right? It's just this conjecture with no supporting evidence for their assertions that, I think you were saying basically they were critiquing your video, basically saying, oh, that's not Polaris. But they never said what it was,
Yeah.
right? They never said what actual star it was.
They just
like
they didn't believe this Polaris.
Yeah.
Well, why would I lie about this? But I'm going to make this up to undermine what really is a meaningless argument in your case. It really doesn't depend upon it. Flat Earth doesn't depend upon it.
Yeah.
And this just it illustrates the fact that they dig in on silly things.
Yeah, it's just that kind of blows my mind a little bit.
And the lockstep devotion to these false ideas that people have, flat earthers, I find it amazing.
And this is something we mentioned before, and I think it's worth mentioning again and again. The goal of this show is for those that are honestly searching for answers. Those that are really looking for answers. Maybe you have a friend, a family member, or you yourself. You're trying to deal with these flat Earth different questions. Maybe you have someone in your church that's trying to deceive you with different things. And so that's what it's all about. Having an open mind to the evidence, not already being convinced in your own mind, because that's the thing that we see again and again. You think about all the lies in the flat Earth movement, right, Danny? So, and you think about if there's a lie that's repeated enough times as widely accepted truth again and again and again, it starts becoming a truth that you just can't shake, you can't get rid of. And so I feel like that's some of the problem here with this flat Earth movement is they've been telling themselves, maybe sometimes unknowingly as well, they repeat the same lie again and again where it becomes a truth, and they automatically filter out every other evidence that does not basically jive with their preconceived
I see that
bias here.
repeatedly happen. You come up with the evidence contrary, and it's like you never said it. They just don't want to hear it. And also, a lot of ideas will suddenly get hatched by a flat earther. It will spread through the community like wildfire. Fire. They are extremely skeptical of anything that anybody outside the flat Earth movement says. But when a fellow flat earther says something, it doesn't matter what they say; they're likely to believe it.
Yeah.
And this is a huge confirmation bias that's going on here.
And you think about it, they're really good at pointing out supposed lies and deceits. And, for example, you and different scientists and different agencies, did they ever take that same standard on their own movement? You think about it.
Well, there is some fighting going on about certain things, but they don't apply the same
They
standard.
think about that double standard.
They have highly skeptical of anything outside. They have absolutely no skepticism for claims within it, and they will repeat among themselves the the silliest things, and they have echo chambers and they reinforce one another. And when they get out of those echo chambers, they get really upset. I belong to one social media discussion group, and flat earthers don't last too long there because it's not run by flat earthers. The group isn't, and they come in and they're not used to having their ideas tested and questioned, and they get very frustrated and they end up leaving. They get angry and leave many times.
Yeah, and this is something I said before. A lot of Christians are falling into this trap, and
Yep.
what worries me is as Christians, we are called to work to build the kingdom. We're called to be studying, being in the Word daily, and to be preaching the gospel. And I feel like a lot of these Christians nowadays that are buying into this flat earth movement, think about how many hours a week you're spending in, researching different flat earth conspiracies versus actually doing what you're supposed to be doing and what
Yep.
God has actually called you to do here. Something I said last time, Colossians 2:8, don't let anyone capture you with empty philosophies and high-sounding nonsense. So, we urge Christians today, don't be captive, don't be taken captive by this type of empty deceit and just this nonsense that's happening all around us here. So, Alex, real quick, he says, Professor Faulkner, you are admirably conservant. Conversant. Thank you for standing up to the flat earth trend. I am new to this recent phenomenon. So,
That's very good.
so
Thank you. I
there.
appreciate
Thank you,
the
Alex.
confidence there. I want to mention, tell people, unfortunately, next week will be our last show. When we launched this program, a month and a half ago.
Has it been that long
was
already?
it was in November, yeah.
Man, time
And
flies.
we did it kind of as an experiment, and we learned what we were doing. Unfortunately, we have some scheduling conflicts coming up here at the museum, which will make it difficult for us to continue doing this. I would love to come back and do this again. It was kind of like an experimental thing. Do it in a different way a little bit, perhaps, but we will be here next week, kind of wrapping up, continuing what we're talking about here, rebutting some of the claims that flat earthers make. But I'm kind of sad because I enjoy doing these programs.
Yeah, it's fun.
And I
been a
hope
good
we can in the future relaunch this and do it all over again.
And again, if you guys want to get a head start here, check out Danny's book, Falling Flat here, available on our online bookstore as well as here in the Creation Museum. Also, make sure you check out all the online articles we have on our website. Just jump on the answersingenesis.org, go into the search bar, type in flat earth, and you can spend millions of years on our website.
True, you can.
Long time on our website. Plenty of reading out there. And like we were saying before, make sure you guys stay curious. Keep examining, keep looking out into creation. Psalm 19:1, the heavens declare the glory of God. So let's continue to keep searching God's creation, having a proper understanding of God's creation too. I feel like if we don't have that proper understanding, we're actually distorting the power of our Creator. So it's very important as Christians that we understand the way that God created everything around us, the sun and the moon and the stars and their purposes. So again, make sure you guys stay curious, continue glorifying God with everything you do with word, thought, and deed, and just love God with all your heart, soul, mind, and strength. That's the greatest commandment. So and that's why we're here, guys. We are a biblical authority ministry. We love helping you defend the faith, giving you answers to help defend the faith, standing on the Bible alone, but we're also a gospel-centered ministry. We're all about pointing people to the hope of Jesus Christ. So if you haven't repented and put your faith in Jesus Christ, today is the day of salvation, is what the Bible says. Repent and believe in the good news, and you will be saved from the wrath to come. All right, guys. I think we're going to wrap up. Any last comments?
Good night, Tune.
Yeah, good night, Tune. And by the way, if you guys are wondering, Danny's not wearing shoes, again, like usual. And Teddy, do you have any final words back there? You've been kind of silent tonight.
Yeah, he's been kind of quiet
A
lately.
little quiet lately, so. All right, Teddy, Danny, we're going to go ahead and sign off. Thanks again, guys, for joining, and we'll see you next week.